Hi everyone, welcome to Last Minute Maths again. And in this video, we're going to look at the binomial probability distribution. And what I'm covering in this will be suitable both for the GCSE Further Maths, the OCR syllabus, and also the introduction bit to A level. All right, so it's fairly comprehensive. And I don't know, to avoid boring everybody to death, let's just jump straight in. Okay, what do we mean by the binomial probability distribution, right? The first thing, it's if you have an event, right, which has only two outcomes, right, two possible results, that is effectively a binomial, i.e. hence bi, right? So the example is rolling a die, right? And yes, before everybody corrects me, a singular of dice is die, right? So I'll stick to the correct version. The two outcomes, for example, can be getting a 6 and not getting a 6, right? The most obvious example would be, for example, tossing a coin. And let's say heads is what we want, or you can have a tails, heads or tails, all right? So any event where there is what we call a success and a failure, all right? And we'll come back to that in just a moment. So when this type of event is repeated, all right, a number of times, all the possible results that you can get form a distribution. And that's what we mean by distribution. So if I take a particular example, roll a die 5 times, all right, and we want a 6 to be a success, all right? So when you're playing a board game or something, you need a 6 to get something special. That's a success. So the number of sixes can be 0, 1, 2, 3, 4, or 5. All right. So that is effectively the distribution of the possible results. And each result has a probability of its own. All right. And all the probabilities, if I were to actually write out all the probabilities under each one, like that, all right, whatever the numbers are, then that would make up a probability distribution, which in this particular type of event where there's only two outcomes, it's called a binomial distribution. All right, that's what the binomial is. That is written as x squiggle, all right? So in other words, x is distributed binomially. So x is distributed binomially with two values that actually define and tell you what this distribution is all about. And that's n and p. The explanation for all that. X is the number of successes. All right, that's x. The n value in the brackets, that one there, that's the number of events. In other words, the number of times you're repeating the event. And p, all right, that is the probability of success. All right. So in our particular example with the die, you say the number of successes is how many sixes we get. All right, so that's that. N is how many rolls of a die. So the number of times we're rolling the die. All right, so that's that one. And as you know, the chance of getting a 6, that is effectively 1/6. All right, so that's your P there. Okay, now one very, very important point, and you must note this. Only valid if events are independent. All right, so each event has the same probability of success. So every time you roll a die, the die is rolled, chance of 6 or P of 6 is always 1/6. It doesn't change. Same way, if we're tossing a coin, every time we toss a coin, the chance of getting heads, for example, is always a half. All right, so it doesn't change from one event to the other. Hence, they are independent. Okay. Right, now the actual probability and the possible combinations. So here's a whole lot of information about what we've just talked about. The same die example, let's say 6 is your success, all right? So S is denoting number of successes, right? A not 6 is a failure, all right? F, okay. Then we have 5 rolls, so N equals 5, all right? P of 6 is 1/6, so therefore little p, the parameter in the actual binomial distribution, all right, is 1/6. And we need one extra bit, one other little bit of information, is the probability of not 6, all right? And that's given by Q equals 5/6, because Q equals 1 minus P. If P is a success, then 1 minus that must be a failure, all right? So P equals 1/6 is the probability of a success, and Q is the probability of a failure, all right? Okay, armed with all that information, let's work out how to actually use it now. That's the most important thing you need for your exams and your tests and questions, etc. So number of sixes is a binomial distribution, which is defined by parameters that we've just talked about. X is the number of sixes, and the binomial distribution has 5 events, and the probability of success is 1/6. That is what you need to actually do any calculations in a binomial distribution question. Right, using it. So if we start with the fact that X has a range of values going from 0 sixes up to a maximum of 5 sixes, all right? Remember, you cannot have any outcome more than the number of trials. So I can't roll a dice 6 times, for example, and get 8 sixes, right? It's not going to work. So be careful with that. Right, so the first example for 0, all right? For 0 sixes, effectively, we've got a failure, 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 and another failure. So that's the probability of a failure, 5/6, times 5/6, times 5/6, times 5/6, times 5/6. Goodness, try saying that a few more times. So that is basically 5, 6 to the power 5, all right? Nice and simple. There's no other way of arranging it. It's straightforward. But as soon as we go on to other combinations, all right, so for 1/6, you can see if I were to actually write out each of the examples here, you can see I can get a 6 on the first throw, a success on the first, and then 4 failures. Or I can get a failure, a success, and then 3 more failures, and so on. So effectively, if you write out all the possibilities, you see that there is 5 different combinations. There we go. All right. So the probability is when you have different combinations, different ways of arranging the same result, if you like, then you've got to multiply the probability by the number of combinations. So here we have 5, and then we've got the probability of 1 success, and then 4 failures. All right. So 5 times 1/6 times 5/6 to the power 4. All right. So hopefully that makes sense. And so on. Okay, you could do that for all of them. And honestly, don't bother. There's a much simpler way of doing it. And the formula that you need for this, right, for any given number within a distribution, is this thing here. Given that you've got any binomial distribution, all right, with n and p given to you, okay, then the chances of p of x equals r, meaning r successes, out of n events. Oh, and for those of you I know doing your A-level or are really, really strict about your terminology, we also refer to this as trials. The number of events is also called the number of trials, all right? But let's try and keep it simple here. So R successes out of n events, all right, is given by something called NCR, all right, which I think I've covered in a different video earlier. And the probability of success to the power R, because R successes, and the remaining, okay, however many there are left, would be failures. So that's n minus R, all right. It doesn't really bear much discussion. Just make sure you actually remember the formula, or if it's given in the formula sheet, know what to plug in to each of those values. And so NCR, that's the important bit, that tells you the number of possible combinations. All right. And for that, you're best off just using a calculator in a calculator paper. All right. So again, little diagram here. It's that button there, all right, the division button. So for example, if I wanted to work out how many different ways I can arrange 3 items out of 5, or let's say 3 successes out of 5 events, all right, the way I would do it, step by step, press 5, then press Shift followed by the divide button. All right, so that's your NCR button. All right, Shift, divide, and then 3, and then the equals button, and the result is 10. So effectively, there's 10 different ways of arranging 3 successes out of 5. All right. If, for example, it's a non-calculated paper and they actually want you to work it out manually, then this formula is the one that you need for NCR. That's the actual thing that your calculator is working out for you. So if it's NCR, R out of n events, this thing is called a factorial. Up here, the exclamation sign after a number is a factorial. I'll explain that in just a moment. The formula is there. It's n factorial divided by r factorial, i.e. the number of successes, factorial, and then obviously the number of failures, factorial. All right? So you could write it like this. Like that, all right? In the binomial expansion, that is. What does a factorial mean? So here, for example, 4 factorial is simply the product of 4 times 3 times 2 times 1, all right? If I wanted, I don't know, 7 factorial, all right, then it's 6 times 5. What am I saying? Goodness, it must be late in the day. Start again. 7 times 6 times 5, etc., all the way down to 1. All right, so that applies to any number. A number factorial is itself times all the numbers, one after the other, down to 1. All right. Okay, and just in case you're wondering, those of you familiar with NPR, the button next to it, you don't need it for binomial distribution. Okay, that's a completely different thing altogether. A different way of arranging things. Don't need it here, don't worry about it. Okay, in our particular example, coming back to where we had 3 successes out of 5, if you want to work that out, using the formula, again, remind ourselves of the formula that we looked at previously. Okay, so that one there, all right. So populating that formula with our particular example, 3 successes out of 5 events or 5 trials. So you got 5C3, the probability of a success to the power 3, and the probability of a failure to the power 2. All right, so that's success and that's failure. All right, when you put all of that in your calculator, you get NCR for 5C3 comes out to be 10, and the product of all the the probabilities in your calculator come out to be 25 over 7,776. Okay, all of that, work it out, bung it in the calculator, and you can leave it as a fraction, all right, in lowest or simplest form, or you can put it in as a decimal, all right, to a sensible level. In this particular number, I'll probably cut it there and not go any further than that. That's more than enough, all right? Okay, the next thing you need is cumulative probability, okay? Cumulative means a number of probabilities added together, all right? So up to and including, for example. So in my same example, you've got the 0, 1, 2, 3, 4, 5. All right, so let's say I want the probability that I get, all right, 2 or less. When you guys get this in a question, be careful to actually look at what the question says, all right? 2 or less, 10 or more, whatever it might be, work out in your head. If necessary, write out a number line like this, right? And then say, which one do I want? So I want this and down like that, 2 or less. So the ones I don't want are those ones, all right? And so on. So for small numbers, I think probably up to like 6 or 7 events or something like that, you can probably calculate each individual probability like I've done here and add them together, all right? But for large distributions, use the cumulative function in your calculator, which I'm about to show you now, all right? Okay, how do we get to the cumulative distribution, the binomial distribution? In your calculator, all right, look at, press the menu button, and scroll down to 7. So that's there, the distributions, all right? So menu 7, okay? And then scroll down once, all right? Scroll down just once, and you come across this thing, binomial CD, all right? CD is what tells you it's cumulative, all right? So pick that one, yeah? Press 1. Next, it'll ask you, is it a list or a variable? Usually the one that you want is going to be a variable. A list is, you could give it all sorts of like different values. Like so the probability of getting a 1 or a 5 or a 6, something like that. You can put them in individually. The one that you need for your tests, your exams at this stage, is the variable one, all right? So stick to the variable, and that will give the probability of less than or equal to, all right? So it always gives you the lower end of it. So less than or equal to a value that you input. All right, okay. So for our particular example, in this case, what have I done? Yeah, I've taken 2 or less. So P of X is less than or equal to 2 out of 5 events. All right, and remember P is 1/6. Okay, so there you go. X equals 2. All right, that's that one there. N, number of events, is 5. So 2, 5. And enter the 1/6, whichever way you prefer, any which way you like. So that's your 1/6 there. All right. So when you put all that in, press the equals button, and you will get your actual probability result, which I've truncated. If you're actually using it in calculations, I've truncated it at 4dp. All right. So that is the way to use your cumulative distribution in the ClassWiz calculator. All right. Okay, so for example, if we then extend that idea a little bit further, all right, what if we want P is greater than or equal to 2? So in other words, more, well, let's say, no, let me rephrase that for a second. All right, so if I say 2 or more, All right, okay? So effectively, I want that result and everything above it. What I don't want is that one and that one. All right. So if it confuses you, if this type of conversion from going from less than or more than whatever, if you find it confuses you at all, then just draw out exactly the way I've done it here and do a little number line and tick or cross out what you want, what you don't want. And then hopefully it'll be absolutely clear exactly what number you need to use or put in your calculator. So in this case, I could, if I wanted, actually calculate the probability of 2, probability of 3, 4, and 5 and add them all together. But it's a waste of time when you can use a calculator if it's a calculator exam. All right. So it's quicker to find the probability of x or less. X equals 1 or less. All right. So 1 or less. All right. And take that away from 1. Remember, the sum of all probabilities, all probs, equals 1. So if I find out what 0 and 1 are, then if I take that away from 1, it'll give me the probability of all the other options put together. All right. Look at that again. Rewind the video if you need to and look at it again and just make sure you understand what we're doing with the number line. All right. So mathematically speaking, the probability of x is greater than or equal to 2 is the same as 1 minus the probability of 0 and minus the probability of 1. All right. So probability of 0 and 1 put together, take that away from 1 and it gives you the probability of getting 2 or more. All right. Now, the reason we do it from that perspective is because the calculator gives the lower end of the scale, lower end. All right. We'll give of number lines. So whenever you put in a variable, it will always give you the probability up to and including that number, not the upper end of the number of number line. I hope I've managed to explain that well enough. All right, so I hope you can understand that you can either get like something or less, or if you want something and more, right, equal to or more, then you take the lower end of the number line away from 1, and that'll give you the top end. Okay. And examples, I mean, let's say, for example, just to finish off, if you have 20 throws of a coin, all right? So 20 throws of a coin, I should say tosses, I suppose, but throws of a coin. And heads is success, all right? Is your desired outcome. Then the resulting distribution will be x is binomially distributed, all right, with n equals 20, and the probability of heads, we all know, is half. All right. That will actually give you all the binomial parameters, what you need to put in a calculator, or indeed, if it's a couple of calculations, you can do that manually. But that's the sort of number where you would use a calculator. All right. And so if I wanted on a number line, let's do a really simple one. Okay. The number of heads, 0 to 20. All right. What if I wanted the probability of getting 12 or more? So if I wanted P of x's greater than or equal to 12, all right, then what I want is to cut away everything that's below 12. So 11, all right, let's switch the colors here a bit. Okay. So I want to get rid of everything there. All right. So effectively up to 11. Get rid of that. Okay. So that's going to equal 1 minus P of x is less than or equal to 11. All right. So up to and including 11, get rid of everything up to and including 11. Leaves 12 or more. Okay. I do hope that's helped a little, and go over it again, rewind the video, or pause certain bits and just make any notes you want. But I hope that's helped, and anybody using it for that last exam, good luck. All right. If you've come across these videos for the first time, I will be doing a lot more, many more videos over the summer to try and build up a library of these specific topics for GCSE and A-level maths and sciences. So please do consider subscribing and switch on the notifications, and hopefully these will come in handy at some point or another. Any suggestions, any useful advice, comments, please do post them below this. And if anybody has any special requests for revision, then let me know, and I will try and turn it around as quick as possible. So anyway, good luck with the final exam, and everyone else, I hope you all have a great summer. Thank you for watching. Take care.